Today we are going to discuss about series combination problems. Okay, right. Observe this. There is an inductor of 100 millihenry and a resistance, and there is a source. V is equal to 6.25 volt and omega is equal to 50 hertz. Omega, angular frequency. Good. It is whenever it is whatever is given, almost like in say by default I calculate XL XC if it is there. Okay. I don't think we can solve any problem without calculating XL XC value. Okay. So no need to read the question. Once it is given, calculate X and XC. So R is equal to 3.75 ohm and XC is equal to omega L, right? That is equal to, what is omega? 50. L is equal to 100.
Sir, XL is equal to omega L.
XL is equal to omega L and 50 into 100 milli 10 power minus 3. That is equal to how much? Tell me it is.
0.1.
This is 0.1. Huh?
No, sir.
Okay.
Sir, 5.
5 ohm. Okay. By default, we calculate. After this, what we do? Then we write voltage phasor and current phasor. We write voltage phasor and current phasor. Actually, current phasor won't be there. Voltage and current together, single phasor we write. Then we calculate. Further. Okay. First, we write the phasor. I'll explain how to write. Just a minute. Just a moment. Focus here. I'm going to write voltage phasor. This is VR, VL, and resultant V will be like this, right? Obvious. Then the resultant voltage, the sum or total voltage will be 6.25. It's given. So I'm writing given data. Then this is current I. Clear? Next, we need to write resistance phasor. Okay. Remember, resistance phasor is not there. In CBSE, you should not write. But I'm writing here resistance phasor 3.75 and this is 5. Now resultant will be how much? I can say like this. This is 1.25 into 4. This is 1.25 into 3. Right or wrong? So it's like taking a Pythagorean triplet 3, 4, 5 and multiplying with 1.25. 1.25 into 3, 1.25 into 4, 1.25 into 5. 6.25, right?
Yes.
Right. So the angle will be 53 degrees, right? The 6.25 it is. And this is 53. And remember, these two are similar. They are similar. That's a key point. Okay. So 53, 53. Now, once you have 53 here, this is 6.25, na? Then of course, the ratio is 1. That means current is 1 ampere. And this ratio must be 1. This ratio must be 1. No need to discuss. So there's a value. Now, whatever you want, you can calculate. So if they ask like this, total impedance 6.25. Current will lead or voltage will lead? Voltage will lead. By how much angle? 53 degrees. What is the current value? Current value is equal to V by I. You can take this by this, or this by this, or anything you can take. Because in series current is same. You take voltage drop across inductor, that is 5 volt, and XL. You take anything. I is equal to 1 ampere. Actually, I haven't read the question. I saw the question, I continued. Okay, I don't know what they want. In the given phasor, okay, in the given LR circuit, make phasor diagram for voltage and impedance, calculate impedance of the circuit. 6.25. Current in the circuit, 1 ampere. Phase difference between current and voltage, 53, voltage leading or current lagging. Done. That's it. Go ahead with the next question. As I told you, I don't read the question. Simply when inductor or capacitor, whatever is there, I calculate XL or XC value. R is equal to 10 ohm. Good. R equal to 10 ohm. Then XL is equal to omega L. It is equal to omega. What is omega? 1 kilohertz. 10 power 3 into 10 into 10 power minus 3 millihenry. Na? These two gets cancelled. So XL also 10 ohm. And in the circuit only inductor and resistance is there and they're in series. Now you need to make the phasor. Voltage phasor I'm going to make. We have resistance, so VR. We have inductor, so VL. The net, the total source voltage will be equal to this one. VR, VL we don't know, but we know the source voltage because it's given as 5 root 2. So it is 5 root 2 volt. And current will be always in phase with resistance. This is what we know. We don't know this angle. If we know the angle, everything is done. So component I'll take and I'll get VR, VL, I, everything I'll get. But we don't know the angle. How do we get that angle? We have to make the impedance or resistance phasor. Right? We have to make the resistance phasor. So first of all, I take resistance R, inductance, that's also 10. Both are 10 only. Now the net value is Z. It's obvious, na? 10 and 10 perpendicular to each other. Resultant will be what? Tell me. 10 root 2. Obvious, right? Yeah. And this angle is how much? What is the angle? 45 degrees. This is 45. This is also 45. This is 45 degrees. This is 5 root 2. 5 root 2 cos 45 is 5. And this will be 5. And if you want to find current, total voltage by total impedance, or this by this, or this by this, anything you take, that will be the current. Current must be equal to 0.5 ampere. Actually, I haven't read the question up to now. I got everything, whatever is, I don't know what they asked. Part A, what they asked? Total impedance. Very good. 10 root 2. Voltage across inductor and resistance. 5 volt and 5 volt. Current 0.5 ampere. Over. Done. Solve next one fast. I'll start. R. Resistance R is equal to 3 ohm. And XC, capacitor is there, is equal to 1 by omega C. That is equal to 1 by omega 2 kilo 2 kilohertz means 2 into 10 power 3 into C, 125 micro, 10 power minus 6. Okay, right, 1 by 2 into 125 is 250. 10 power 3, 10 power minus 6, 10 power minus 3, and it goes numerator, it becomes 1000. 1000 by 250. If you cancel, it will be 4 times, check it. 4 times. 4 ohm. I got the capacitive reactance and resistance is already there. First, what we do? We make voltage phasor, right? Yes, we'll make it voltage phasor. Just a minute. Right. Voltage across resistance, VR. Voltage across capacitor, VC. Total voltage 10 volt. That's given. 10 volt is given. And current is I. That's it. We don't have any data. This is a phasor. Now, what next we need to do? Standard stuff, right? That is impedance phasor. Remember, in CBSE, we don't deal with impedance phasor. The method is different. Now, we have resistance 3, capacitive reactance 4, 3, 4, obvious, na, Pythagorean triplets. And total impedance will be 5 ohm. Now, what does this angle tell me? 53 degrees. Then this is also 53 degrees. Sorry. This is also 53 degrees. Now, once it is 53, 10 cos 53, 10 sin 53. What is 10 cos 53? 6 volt. 10 sin 53, 8 volt. Then what is current? I is equal to V by R. Total voltage by Z. Voltage across inductor by, voltage across capacitor by capacitive reactance. Anything you can take. 2 ampere, right? That's it. What is the question actually? I don't know the question. First one is what? What is impedance? Yep. 5 ohm. Total impedance. Phase angle 53 degrees. Current is leading, voltage lagging, because you know very well, phasor will rotate anti-clockwise. So current is ahead of voltage. Good. What next? Current 2 ampere. Done. That's it. Now it's a matter of practice. How much practice you do. In series combination, when you have LCR, what to do? Nothing. Follow the same rules. R is equal to 5 ohm. Yes. And XL. XL is equal to omega L, right? Omega is 1 kilohertz, 10 power 3. L is equal to 5 millihenry. 5 into 10 power minus 3. So XL is equal to 5 ohm. Good. XC. XC is equal to 1 by omega C. That is equal to 1 by omega. What is omega? 10 power 3 into C. C is equal to 100 micro. 100 into 10 power minus 6. Good. That is equal to 1000 by 100. 10 ohm. 10 ohm. 10 ohm, 5 ohm, and 5 ohm. Now we need to make first voltage phasor, but we can't do anything with it. Then we have to go make the impedance or resistance phasor. then compare, solve, over.
Yes, sir.
Now we have to go for voltage phasor. First, VR, VL, VC. Why I'm making more VC here? Why I'm making more VC? Because we know XC is more, na? That's why, because they're similar triangles, we can predict just rough estimation. Then V, total voltage. Total voltage is given, right? 4 volt. That's the only data given in this phasor. Angle we don't know. Current also we don't know. Now I'm going to make the phasor impedance phasor. Okay. First resistance, XL, XC, resultant will be Z, angle is theta. Now it's a matter of substituting data. Entire data is there with us. What is XC? Sorry, yeah. What is R? R is equal to 5 ohm. Sorry. R is equal to 5 ohm. Then XL. What is XL? 5 ohm. Then XC. What is XC? 10. So if you observe 5 minus 10 or 10 minus 5, 5. So it will be 5 down. This is also 5. Then Z is equal to 5 root 2, right?
Yes, sir.
5 root 2. Theta is 45 degrees over. Then we can solve everything. This theta is same here, 45 degrees, and they are similar, right? Right. It will be V cos 45. 4 cos 45 is 1 by root 2, 4 into 1 by root 2 root 2. 2 root 2. And if you want to continue or take similarity, right, ratio, this by this must be equal to this by this. So we can conclude VL also 2 root 2. VC will be 4 root 2. I will be 2 root 2 by 5. Yeah, keep it as it is. If you want, you can simplify 0.4 root 2. 0.4 root 2. Depending on what is the answer given in the options, that's it. So answers will be 5 root 2. Impedance is 5 root 2. Voltage will lead or current will lead? Current will lead by 45 degrees. And 2 root 2, 2 root 2 and 4 root 2. Voltages across inductors. Now the next question comes. What is voltage across inductor? I'm extending the question. 2 root 2. Voltage across capacitor? 4 root 2. Voltage across resistance? 2 root 2. And the total voltage is 4 volt. See, I don't know how come sum of these three will be equal to 4. Vector sum is fine, but when I apply Kirchhoff law, check it. Kirchhoff voltage law, algebraic sum of individual potential difference must be equal to 0, right? So this minus this must be equal to sum of these three. But how come sum of these three, you add them or subtract, doesn't matter. It won't come, na? If you want to subtract these two or whatever.
Point is VC is equal to V sine 45, right? Which is 4 by root 2.
Why?
Which will be
My point is very simple. I'm not, see, you can say like this, sir, you taught me something phasor. Okay, you taught me something phasor. Everything is fine, accepted. But if I go through fundamental law, Kirchhoff voltage law, what it says, tell me. Potential drop across this, plus this, plus this, plus this must be equal to 0, right?
yes, sir.
Okay, I'm telling you, you're blindly believing it. I appreciate. You should not add blindly, you have to add vector according to vector addition. But how come?
No, sir. The point I'm coming to say is in the phasor diagram, VC, I guess, is wrong
Oh, VC is wrong.
because it should be 2 root 2.
VC is 2 root 2.
Yeah, because V sine 45. 4 into 1 by root 2. It will be 2 root 2.
V sine 45.
Huh.
V sine 45 is VC.
Yes, sir.
Okay. Then Z sine 45 must be XC. I've sent a YouTube link on resonance. Okay. In CBSE, we don't use this impedance phasor. In reality, it doesn't exist. Voltage is phasor, current is phasor, accepted. Impedance is not phasor. Impedance won't rotate. But still, now it will work for us though we are making it. In CBSE, what they do is that very simple. They write the phasor. They calculate net voltage. Okay. So then they write like this. They write V is equal to VL plus VC plus VR according to vector addition. And they go through they calculate I. From I they calculate Z. How do they calculate in CBSE is discussed there. Just go through it. It will save some time for me. Okay. So brief idea, I'll give it to you. What is resonance? You must go through the video. What is resonance? It's very simple. See, in this case, what happened is that omega is in such a way that XC is more than XL. But if you keep changing omega, if you increase omega, XC will decrease. XL will increase. As the XL increases, XC decreases, this phasor will slowly move towards the R. At one particular value, the Z will superimpose with R. Means what? XL and XC both are equal. Suppose if you take the Z value as a formula, Z is equal to R square plus XL minus XC whole square under root. This is the impedance, right? Sir, if you are taking XL is more than XC, even XC is more than XL also it will work because whole square, na? No problem. So this is the Z value always. Check it. If you are interested, you blindly substitute the data, you will get the answer. Vector addition only. First of all, subtract these two because they are opposite to each other. Then whatever resultant you got and use vector addition, Pythagoras theorem, because they are perpendicular. Over. Now if you see, Z value is minimum when this is 0. Sir, why not be negative? No, even if it is negative, the total value will be positive only. The minimum value, because square is there, the minimum value is 0. Minimum value is 0. That means what? XL is equal to XC. That is omega L is equal to 1 by omega C. Omega is equal to square root of LC. This is resonance frequency. This is resonance frequency. Once we got this resonance frequency, we can conclude that at this moment, XL equal to XC and voltage will be in phase. Voltage will be in phase and like this it will be. This is the resonance frequency, okay? At this moment, resistance is minimum, current is maximum. Detailed discussion is there in the video, you just go through it. Clear? This is about resonance you need to study. Okay. You must go through it, just 10 minutes video, 10 or 12 minutes video, that's it, okay? You must go through it. Then we go for question number 10. 10 will give you complete understanding. Okay, carry on. Up to now, we don't have any issue with is it RMS or peak value. Why? Because they gave voltage, they asked voltage, that's it. They never gave specifically maximum voltage across the source. Calculate RMS across inductor. The RMS means what? Whatever the voltage they gave, if it is maximum, whatever answer we gave is maximum. See, they said 4 volt. 4 volt is maximum or RMS? We don't know. Of course, by default, we say like this. If it is not mentioned, whatever voltage is given, it must be RMS value only. So, but still it's okay. It may be peak value also. I don't know what he gave. Now, what answer we give? If he gave peak value, this is the peak value. If we give RMS value, this is RMS value over. RMS peak doesn't matter here. In this question, RMS and peak does matter. So remember, this is peak value, M, maximum peak value. Okay. If it is peak value, what to do? Don't do anything, simply continue. You get peak value across each circuit element. Nothing else is there. Okay. Right. First thing we have to calculate XL, XC and standard stuff. R is equal to 10 root 3 ohm. XL is equal to omega L. That is equal to 2 into 10 power 3. 2 into 10 power 3. L is 6 into 10 power minus 3. These two gets cancelled. 2 into XL is equal to 12 ohm. XC is equal to 1 by omega C. Right, let us write the formula also. 1 by omega C. So that is equal to 1 by, what is omega? 2 into 10 power 3. What is C? 250 microfarad. 250 micro means 10 power minus 6. If you go through calculation, 10 power 3, 10 power minus 6 will be 10 power minus 3. It go to numerator, it becomes 1000, right?
Yes.
1000 by 250 into 2, 500.
2.
Yeah, 2. Just a moment. XC is equal to 2. We got this, and this. We got 3 things. Then standard stuff, we make the phasor, make it fast. I'm going to make the phasor. Voltage across resistance, voltage across inductor, voltage across capacitor. Now what next? The resultant voltage will be like this. VL is more, yeah, because how do I know? XL is more than XC, right? Then VM, the VM is equal to what? 10, that's the given data. Theta and I, that's what we know, nothing else apart from that. Now we need to make the impedance phasor, make it for impedance phasor, everything data is there. Resistance 10 root 3 ohm, inductive reactance 12, capacitive reactance 2. Yeah. What the value? 12 minus 2, 10 here, 10 and 10 root 3. Resultant will be 10 and 10 root 3 is 20, right? Yeah. And theta, angle is theta. Theta will be 10 and 10 root 3 is sin 30, sin, yeah, 30 degrees, not sin, 10, 30 degrees, right? So 20 and theta is equal to 30 degrees. Once you got 30, that's it. This is also 30. And voltage is 10. 10 cos 30. 10 cos 30. Cos 30 is 1 by 2. 5, right? 5 root 3.
Yes.
Cos 30, no? 5 root 3. And I'll go for ratio. The VL is equal to 6. VC is equal to 1. 1 volt. Yeah. That's it. We made the phasor. But anyway, still we need to solve the question. We made the phasor. Up to this is fine. Calculate voltage across capacitor when current is in the circuit is 0. Huh? What is this? Calculate voltage across capacitor when current is 0. Up to now, I haven't seen this. Actually, you need to understand like this. That is what, whatever these phases are there, na? The phasor is not at rest. Actually, it is rotating. I was not able to rotate about the center, but it rotates like this, right? It keeps on rotating. At any given moment of time, if you want to find the voltage, how do you find voltage across anything? Take component onto y-axis. I discussed already. Actually, this is we consider this as a phasor. Check it, phasor. See the diagram. See that it is phasor. So, although phasor is rotating, like this, component of the phasor onto y-axis will give you what? Instantaneous value, right? Now, read the question. Read the question. What they're asking? Calculate voltage across capacitor when current in the circuit is 0. When current in the circuit will be 0? When current phasor is 90 degrees with the y-axis. Oh, same position. Fine, fine. Now, what next we need to do? Yeah, we have to continue. Now, voltage across inductor. Remember, this is the peak value. What I'm writing is that current value. So, to make the difference, I'll use small v. VL is equal to 6 volt. VR is equal to 5√3 volt. Tappu. No. Current instantaneous values. At this moment, what value it is? That's instantaneous. That is 0 because instantaneous values is component onto. Yeah. VC is equal to 1. No, -1. Calculate voltage across capacitor when the current in the circuit is 0. When the current in the circuit is 0, that means voltage across capacitor is -1 you can take. Or you can take one more point also. Observe. If you observe closely, current across current circuit is 0. Even in this case also. At the time it is +1. Voltage across capacitor is +1. You can take anything. So answer is +1 volt or -1 also you can say. Next one. What they're asking? What these are the instantaneous values at this moment values. 6, 10, 5√3, 1 are maximum values. Okay. Right. So what I do, I will copy the same diagram once again and I'll solve. What is the next question? Tell me what is the next question. Someone read. Next part B.
Sir, calculate voltage across inductor when voltage across resistance is maximum.
Voltage across resistance is maximum means component of resistance, voltage across resistance should be maximum means it should be along y-axis, right? Suppose if I take it at some other angle, some random angle I'm taking. At this moment, component of VR onto y-axis less than 5√3, na? It is maximum means what? It is totally along y-axis. This is the condition. In this condition, voltage across inductor will be 0 because check it, component onto y-axis 0, na? Voltage across capacitor is 0. Voltage across resistance is 5√3. Wait. At this moment, what is the voltage across source? It is not 10. 10 cos 30. 10 cos 30. What is the value? 5. Now you see. I asked you, na, how come Kirchhoff law is applicable? Now I'll show it to you. Kirchhoff law is a rule of God. It cannot go wrong. So remember, whatever we are calculating, they are what? Peak values, not instantaneous values. These are instantaneous values. And observe, now what is the voltage across source? V sine 30. Sorry. Yeah, correct. V sine 30. So voltage across source is equal to V sine 30. That is equal to what? 5 volt. So at this instant, voltage across inductor is, sorry, voltage across source is 5 volt, right? Voltage across
Sir,
inductor is,
written V is equal to 10 cos 30, that's equal to 5. 5 root 3.
V is equal to 10 cos 30. Yeah. Why 10? Where I wrote?
The one below. Second case.
Okay.
Where,
What's the problem there? I don't understand.
sir, 10 cos 30 means it will be 5 root 3, right?
Correct. It's okay. Thank you. I'm looking into cos 30 and sin 30 because that's what my focus is on. Okay. Now focus on this. Voltage across source is 5 volt. Okay. Voltage across inductor is 6 volt. Voltage across capacitor is minus 1 volt. Voltage across resistance is 0. So check it. 5 is equal to 6 minus 1 plus 0. Okay. Now let us come down to the second condition. That means at some other angle or some other time, I can say. Let us take the voltages given. Voltage across source 5 root 3. 5 root 3. Voltage across inductor 0. Capacitor 0. Resistance is 5 root 3. Oh, yo. 5 root 3 is equal to 0 plus 0 plus 5 root 3. So what you need to understand is that if the question is asked, how come Kirchhoff voltage law is not valid here? 100% is valid. Kirchhoff law is not for random times. It is at a given instant. You take voltage across this plus this plus this will be same. Okay. C is a, I can say good. C is good. C will give you complete clarity. C will give you complete clarity about our understanding. Okay. So let us go for C. So in case of C, what they say is that voltage across source is maximum. What is the meaning of voltage across source is maximum? Vm must be parallel to y-axis. This is the voltage across source maximum condition. Then let us go ahead with it. Voltage across source V is equal to 10 and voltage across resistance will be equal to 5 root 3 cos 30, right? 5 root 3 cos 30, root 3 by 2. What is the value? 5 root 3 cos 30. Perfect. What is the value? 7.5 VR. Now what about voltage across inductor? VL 6 cos 60. Cos 60 is 1 by 2. 3 volt. And voltage across capacitor is equal to, this is 60 degrees only, na? V cos, direct step, right? 0.5 or 1, 0.5, right? 0.5. Okay, we got the instantaneous voltages. We got instantaneous voltages. Let us write them. Let us see whether Kirchhoff law is valid or not. Source voltage is 10. Inductor is 3. Capacitor is 0.5. And small mistake I'm doing intentionally here. Resistance is 7.5. So 7.5 plus 0.5, 8, right? 8 plus 3, 11. It should be 10, na? Some of these three must be 10. But I'm getting 11. Try to understand. VC is negative because below, na? So minus 0.5. Check it perfectly, it will match. Kirchhoff voltage law is applicable. 10 plus this value. That's it. When the voltage across source is 5 root 3. Last part is a little bit difficult one. Voltage across source is 5 root 3. Check it carefully. Voltage across source, maximum value of voltage is 10. 10. And voltage across source is 5 root 3. 10 cos theta is equal to 5 root 3. That implies theta is equal to what, tell me? 30 degrees. That's not a problem. But you need to understand it can be, see, 1 minute, I'll copy this. Entire thing, I'll make it once again for D. Source is adjusted in such a way that just a minute. Source voltage is adjusted in such a way that source voltage makes an angle of 30 degrees with y-axis because V cos 30 is root 2. But observe two conditions will come. The source voltage can make 30 degrees on the right hand side or 30 degrees on the left hand side. If you go for 30 degrees on the left hand side, this one only, we discussed already. Check it. Source voltage will reach 5 root 3 two times. 30 degrees on left hand side, right hand side. This one we discussed already. This one we need to discuss. So this is 30 degrees, these are 30 degrees, these are 30 degrees. Then take the components, directly I'll write, quickly I'll write. Voltage across inductor will be 6 cos 30, 6 root 3 by 2, 3 root 3. Voltage across resistance is equal to 5 root 3 cos 60 because this angle is 60, na? 2.5 root 3. And this is also 30. Then VC is equal to 1 cos 30 root 3 by 2, 0.5 root 3. The common error will be missing minus sign. And voltage across source will be, that's what they gave, 5 root 3, right? V is equal to 5 root 3. These are instantaneous values. So what's my point is that most of the times questions won't be there on instantaneous values. No, it won't be. No need to worry about it. Only one question. But real thing that helps you, if it is given an exam, I can't do anything. But probability of getting this question in exam is very low. Very, 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 very low. So understand that, understand that the voltages that we are calculating here are not the actual values or instantaneous values. They are either RMS or peak value. They are either RMS or peak value. So instantaneous value will be component of those values onto y-axis at any given instant. And Kirchhoff law is valid at any instant. So last time I'm proving it. V is equal to 5 root 3 and VL is equal to 3 root 3. VR is equal to 2.5 root 3 and VC is equal to minus 0.5 root 3. 2.5 minus 0.5 is 2. 2 root 3 plus 3 root 3 is 5 root 3. Excellent. Finally, Kirchhoff law is valid and whatever voltages we are calculating are not instantaneous, RMS or peak value. So we can't use Kirchhoff law by blindly adding these values. Okay? You have to take the component and deal with it. And remember, probability of this is very, very low. Sorry. More probable thing is that instead of this, I sent you a video, na? YouTube video, I sent it to you regarding resonance. Maybe that question is more and more probable. Something like calculate resonance frequency of this circuit. Resonance frequency, very easy, right? This circuit, if I calculate resonance frequency, I can say if that question is given that Simply they gave you marks. Eduthuko all. If they gave that this question, actually probability is also low, but if this question is being given, sorry, that does means they want you to give marks. Okay, omega L, omega is equal to 1 by root LC. L is equal to 6 millihenry, 6 into 10 power minus 3. What is C? 250. 250 into 10 power minus 6. You have to solve this, that's it. This is omega, resonance frequency. This one, this very easy question. I don't think they will give. If it is given, you are lucky. In reality, everyone will solve. You are not lucky because it doesn't give you any advantage over your friends, right? Or maybe the competitors, those who are competing with remaining, everyone will do it. If you don't do it right, it's a problem. Okay, so you can solve it. 6 into 250, 1500 into 10 power minus 9. So yeah, that's it. And I'll say like this: the probability of getting answer from this instantaneous values is lower than getting a question from resonance. So the video I sent it to you, that will be a little bit more important. That is there in CBSE also. Last part, you check in that video, that's more and more based on CBSE. We don't make impedance phasor. It is just there to solve the problem for us. There is no impedance phasor, it doesn't exist. So never ever use this in CBSE. Clear? That's all. Thank you.